Good morning, everyone. I'm Sahai Sheila from Shriram Engineering College. I'm here to teach about geoprospecting. So, geoprospecting, the word determines what is beneath the Earth's surface, that is, under the subsurface, like locating a soil, rock, strength, or knowing about the aquifers or water or any type of locating that the geoprospecting is being used without excavating anything in case of large scale. So geoprospecting will be the preliminary phase of any civil engineering project. That is to find the physical and chemical methods to determine the location and extent and quality of subsurface materials as like rocks, minerals, or water, or sometimes aquifer even. So objective is to find what lies beneath the subsurface without excavating in scale of large scale, in case of large scale. So significance is like if I want to build a bridge or a dam or a tunnel, I have to know what will be the preliminary phase. How does this rock or a mineral or water or soil will be reacting in case of massive structure if I'm building on the surface, how does it will be reacting on the subsurface? Likewise, we have to check, right? So in case if I have a soft clay or it has some underground cavity or it is supposed to be have a horizontal strata or sometimes it has a strike or a fault in it, then it will be so vulnerable to the earthquake. So we have to decide by using this geoprospecting, raw data should be collected before building a massive underground structure or a surface massive structures. So what are the tools? Like we have two types of methods. One will be involving direct methods, that is, we can see the soil and we can see the rock in it. Another is indirect method without touching or without excavating anything, we can do an indirect method. So direct method will be like involving trial pits and bore holes. Indirect methods will be involving the seismic refraction or electrical resistivity, like to say in two or two, three words. That is, we have to insert a two rods, electrodes, and one will be sending the signal from one side, and other will be the receiver side. So the receiver will be getting different types of voltage or wavelength. So according to the wavelength and the frequency or the voltage received, keeping in that mind, keeping that record, we can say what is present underneath. So this is how the electrical resistivity and a seismic refraction will be working. Next is geoprocessing. Geoprocessing is often referred to as geological mapping and remote sensing. That is manipulating and analyzing a data that is actually collected doing prospecting. So before geoprocessing, we have to do geoprospecting. Then why? Then how the processing will be coming. So definition is it is a systematic process of converting a raw data file because in a geoprospecting, you will have all the raw data. What are the safe bearing capacity? What type of rock you have got? How long it is extend? What is the quality of the rock or a water? And how long the aquifer it is, whether an confined aquifer or an unconfined aquifer? What type of soil it is? Whether it is a lake or a sedimentary rock, it's a metamorphic rock like that, you will have all the raw data. You will put the data into a meaningful map or a 3D model. So for this, we are using like technologies like remote sensing, GIS. You all know the GIS is we can put various data, slope data, rainfall data, rock type data, and we can do analyze also. And photogrammetry. These are the technologies we can convert a raw data file into a 3D elevation models. So how it works is we have to have a GPS coordinates or a satellite imaginary or a sensor recording, and using a software we can layer all the raw data file and we can create a end file with all the data into a 3D model, or a 2D drone photos will be converted into a 3D elevation models also we can convert, and that will be used further in a prediction modeling also. So comparing the geoprocessing and geoprospecting, which is goal activity, what are the outputs in analyzing it. Geoprospecting is to collect the hidden data, and geoprocessing is to analyze the hidden data and mapping it data into a 3D imaginary models. Activity is we have to do a field work, we have to do some drilling, we have to do some sensors to especially in geoprospecting when you go into tools like electrical resistivity, we have to keep two electrodes and we have to send signals, and one will be used for sending the signal, other will be used to collect the signal. So using the signal variations and the frequency, we can know what is lies beneath the surface. Like that, we have to do some activities for geoprospecting. But for geoprocessing, it's like only computer analysis where you put the raw data into a layer by layers and it will create a just that is geographical information software will model and it will give a modeling uh, 3D models. The output for geoprospecting will be the voltage, as I said before, like example, electrical resistivity. We will get the voltage, we will get wave speed. So if the wave speed is some particular type of rocks will have different kind of conductors. Some will be conductors, some will be semiconductors. So according to that, the frequency will be changing. The voltage will be, and the voltage received on the other side will be different. With that, they have like for a particular wavelength, this type of rock is present, this type of minerals is present. That's how the raw readings have been taken in geoprospecting. Geoprocessing is we will get a map. So also we will, I said earlier that we will get prediction modeling. Using that we can find the variability, how like after 10 years or after 20 years, how will be the soil and how will be the layering inside the subsurface, or how will be the rainfall, and or will it be like continuing the same way or it will be changing like that. We can take the risk charts also. So combining all this, we will get a geological mapping procedures. So what are the technologies we have been used and what are the procedure we will be seeing in this slide? That is first is surface mapping technology. This is a tool to create a topographical or geological mapping by observing the land from the above or from a distance, or using a drone or using a satellite. You can do a surface mapping technologies. That is, we are going to take an aerial photo. Exactly like that. Then remote sensing, you all know that it is a most critical technology. It involves sensors, satellites, or aircraft that detect the reflected energy from the earth, or in case there is no light also, you can scatter the light and you can take photography from the satellite also. So it has two type of remote sensing imaging, that is multispectral imaging and the ligament mapping. So the multispectral imaging is satellite like Landsat or IRS use different wavelength of light to identify rock types and vegetation health. So in the ligament mapping is remote sensing is perfect for finding straight lines on the map, which is usually indicate the hidden fault lines are major joints that are critical for dam safety. So this is especially done on the rocks for the dam safety. LiDAR, light detection and ranging. That is used for to measure the distance, like stripping away all the trees and buildings in case I have to measure a distance of a hill or a ground or any kind of shape which is located into in a forest area. So in that time, I will not know the exact shape of the hill or a ground or any water bodies. So I will be using LiDAR, that is light detection and ranging will be used to find the ancient landslides, also the hidden fault located in the forested area. So next will be the photogrammetry, that is using a drone or an aerial mapping. We will be taking different types of photos and we will be overlapping the photos to get into a 3D model. Like when you see in any social medias, you'll be seeing a place in 360 degrees. Even in a Google map, you can see 360 degree. That's how this photogrammetry will be working. So it is used for to know the stability of a steep rock cuttings or a process at any construction site. So this is how the geoprocessing, geological mapping procedure is carried out. Thank you.